right, so how to make a graph? Well, first we need to know the difference between the y and the x-axis. So I always think about a y has that longer tail part. This resembles this line here. So this side is going to be the y-axis. On this y-axis, you're going to put your dependent variable. So remember, a dependent variable is something that you measure. Now, in certain lab experiments, we might be measuring height or mass or distance. Those are all things that you can measure with a meter stick or a scale. Those are all dependent variables. So you would see those on this y-axis over here, written in the title bar here, and notice how also the units are included. All right, so that means that this horizontal line must be the x-axis. And on this x-axis, you have the independent variable. The independent variable, remember, is something that you change or you manipulate. Just like an independent person, you can change your mind 1,000 times. With an independent variable, it's something that you're changing. So it could be that you're changing the amount of water, different amounts of liters of water for different plants. It could be that you're changing the amount of blocks that you put on a scale, just to see how it changes the mass. It could be that you're changing the amount of time that you're allowing someone to run, and then you're measuring the distance that they can run. All right, so let's do a practice graph. So this is an example with one independent variable. That means we're only changing one thing in this experiment. So we're going to be talking about plants. So the effect of temperature on plant growth. So as you can see in our data table, we are measuring temperature changes. So we are controlling the temperature, maybe we have a heat lamp, and then we are measuring the plant height. So that means our temperature is going to be our independent variable because we are changing the temperature. That's independent. So that means it's going to go on our x-axis down here. Notice how also the units are included, degrees of Celsius, just like over here in our data chart. And also, you need to make sure that your numbers are labeled on your graph down here. So, yes, on our graph, we need to go from 8 all the way to 32. 8 is our lowest, 32 is our highest. So we need some range that includes all those numbers. Now, I know you probably want to just write 8, 12, 16, 20 on each of those lines, but you have to make sure that they are in correct increments, balanced increments. So you could do it by counting by twos, 8, 10, 12, all the way to 32. It fits perfectly. Next, you have to put your dependent variable on the y-axis. So whatever you're measuring goes on the y-axis. We're measuring plant height. So you're going to label your y-axis with plant height. And again, you need to make sure that there's increments. So it looks like we need to go from 5 all the way to 50. So a range from 5 to 50. You could count by 5s, count by 10s, but either way, they all need to be spaced out proportionally. So for every 3 lines, it's worth 10 centimeters. So we're going from 0 to 60. All right, then you just need to plot your points. So for our first point, at temperature of 8, you have a plant height of 5. So you're going to go over here to 8 and go all the way up to 5. Notice how it's kind of in the middle. It's not quite on the line. That's just how I space them out. You can always shift your graph over to make sure it's always on the line. But as long as you keep it constant, it's okay. And then you just keep going. So at temperature 12, you're going to go all the way up to 15. So your dot should be about there. You're going to keep going. So temperature 16, go all the way up to 30. At temperature 20, so now we're over here, temperature 20, you're going to go all the way up to 50. At temperature 22, you're going to go all the way up to 40. At temperature 24, we're going to go all the way up to 30. At temperature 28, we're going to be going up to 18. And then at temperature 32, our last point, you're going to go up to 5. So notice how changing the temperature does seem to affect the plant height. It looks like the best temperature would be at 20 degrees Celsius because that has the most height on the plant, 50 centimeters. Also for graphs, you need to have a title. Usually for titles, I like to have a question, some kind of question that this graph would answer. So the question could be, how does temperature affect plant growth? Or does temperature affect plant growth? And yes, as you can see, it does. All right, there's another type of graph that you can do, and it's with two independent variables. So you'll see this sometimes if you're mapping out two different plants or two different runners, or in this case, we're looking at plant growth again, but however, we're changing two things. So we're changing the type of soil. As you can see, we're going to be using an organic soil and a regular soil. And then also you're changing the amount of time that you allow to pass by. So you have weeks. You have 4 weeks that you allow to pass by. So these are all your independent variables because you are changing the type of soil and the weeks that are going by. Now your dependent variable would be the height or the plant growth. So this is going to be your dependent variable. All right, so let's create a graph. So on our graph, again, dependent variable, something that you measure. You're measuring plant growth, so that is listed over here on our y-axis. Now, with these two independent variables, you're going to want to create time on this x-axis. This is what we're ultimately changing. You're allowing the amount of time to pass by. You can represent the two different soils either by using two different colored dots or two different color bars. I'm going to choose to use bars. Again, you need to make sure that your axis is labeled. So with plant growth, our plant growth looks like the minimum growth was 4.5 and our maximum was 7.6. So we need to make sure we're going from 0 to about 8. So over here on your graph, you can measure out, you can count out how many. 1, 2, 3, 4, 5, 6, 7, 8. So you have plenty of lines that's evenly spaced out, looks good. For your time, you have 1, 2, 3, 4 weeks. So you have plenty of lines. You can have them skip every other one. So week 1, 2, 3, 4. Looks good. Spaced out, it's proportional, increments are correct. All right, I'm going to do a bar chart. So organic soil is going to be represented by a green bar. So for our first week, it is at 5 centimeters. So for week 1, we're going to need a bar chart that goes up 5 centimeters. Week 2, it's at 7 centimeters. So it's going to go all the way up to 7. Week 3, 7.5 centimeters. Week 4, 7.6 centimeters. And now we're done plotting our graph for the organic soil. Now we need a different color for the regular soil. I chose black. So going back to week 1, it's 4.5. So go to week 1, and now with black, you go up to about 4.5. Week 2, it is at 6. Week 3, 6.3. And then week 4, 6.8. So it does look like the organic soil appears to be better. The plants have more height each week with the organic soil. So a title could be, does changing the soil affect plant growth? Or does using organic soil affect height? Or is organic soil better than regular soil? There are several correct answers for a title, and that concludes how to create a graph.